CLT exterior wall assembly, building durable, high performance timber envelopes. Before we begin, this episode is provided for educational and informational purposes only. The concepts discussed are intended to help explain architectural and construction principles and should not be interpreted as project specific design, engineering, legal, or code compliance advice. Every building is unique and always consult with the appropriate licensed professionals and local building codes before applying these concepts to a real project. Have you ever looked at a beautiful mass timber building and wondered what actually protects all that wood from rain, moisture, and weather? Because here's something that surprises a lot of people. The structural CLT panel isn't designed to be the finished exterior wall. Instead, it's only one layer of a much larger system. Today, we're breaking down the one most important detail in modern mass timber construction, the CLT exterior wall assembly. Let's get into it. Welcome back to ACHLAB, Episode 4. I'm Anne, and here we explore architecture, construction, and the building details that make great project possible. Cross-Laminated Timber, or CLT, continues to change the way we think about building with wood. Its structural strength, speed of construction, and sustainability have made it one of the fastest growing building systems in the world. But as impressive as CLT is structurally, protecting it from moisture is what ultimately determines how well it performs over the life of the building. Today, we're going to walk through the layers of a high performance CLT exterior wall assembly and explain why every single layer matters. So, layer 1, the structure. Let's begin with CLT panel itself. Think of CLT panel as the skeleton of the building. It supports the floors, it supports the roof, and it resists structural loads. And in many projects, it even becomes the exposed architectural finish on the interior. But on the exterior, the CLT panel should remain protected. Wood and wood and trapped moisture are never good long-term partners. Instead of exposing the timber directly to the weather, we surround it with layers that manage temperature, airflow, and moisture. And here is layer 2. Continuous insulation. The next layer is continuous rigid insulation. This layer wraps the outside of the CLT panel like a thermal blanket. Unlike insulation installed between framing members, continuous insulation dramatically reduces the thermal bridging. And why does that matter? Because the thermal bridges allow heat to escape through the structure. By placing insulation continuously across the exterior, the building becomes much more energy efficient while also keeping the timber closest to stable temperature throughout the year. The result is more comfortable building with a lower energy consumption. Layer 3, the air barrier. Now, when we come to one of the most overlooked but most important layers in the entire wall assembly, the air barrier, many people confuse the air barrier with the vapor barrier. They're not the same thing. The purpose of the air barrier is to control uncontrolled air movement, and when properly sealed around every joint, opening, and penetration, it dramatically improves the building performance while helping preventing unwanted moisture from entering the wall. And at the same time, many modern systems are vapor permeable, allowing moisture vapor to escape when necessary. That ability to dry it is incredibly important in mass timber construction. Layer 4, batten and the rainscreen. This is where high performance wall designs become really interesting. Rather than attaching exterior cladding directly to the insulation, we install treated batten or furring strips. These create a small ventilation cavity behind the exterior cladding. This cavity is known as the rainscreen, and here the philosophy behind it. We don't assume water will never get behind the cladding. Instead, we design for drainage. If rain enters the cavity, gravity allows it to drain downward. Air circulating through the cavity helps everything dry naturally. And that combination of drainage and ventilation significantly increases the long-term durability of the wall assembly. And layer 5, exterior cladding. Finally, we have reached the outermost layer, the cladding. This is what everyone actually sees. Depending on the project, it may be wood siding, fiber cement panel, metal panel, brick veneer, or composite material. The cladding gives the building its architectural identity while acting as the first shield against rain, sunlight, wind, and daily weather exposure. Although its most visible layer, it only performs well because every other hidden layer behind it is doing its job. And here's the biggest lesson for today's episode. High performance wall assemblies aren't designed under the assumption that water will never enter the system. They're designed so that if moisture does get inside, it has a safe path to drain, a safe path to dry, and that fundamental principle of building science. Don't design for perfection, design for resilience. Cross-laminated timber is also an incredible structural material, but its long-term success depends on thoughtful detailing. Every layer, the insulation, the air barrier, the rain screen, and the cladding works together as one complete building envelope. And when those layers are properly detailed, the result is a building that is stronger, more energy efficient, more durable, and built to perform for generations. And if you found today's episode helpful, consider subscribing for more architecture, building science, and construction breakdown every week. You can even read the complete companion article along with the detailed diagrams and educational resources at achlab.com or and check the description below. I'd love to know your thoughts in the comments and what's one building detail or construction topic you would like for us to cover to break down next. I'm Anne, and this is ACHLAB, where we explore the details that shape better building because details matter. And I'll see you in the next episode.